My name is Seung-ki Joo, a professor of Seoul National University, School of Material Science and Engineering. This is the introductory course to discuss about the unit process for VLSI fabrication. There's no regular textbook for this course, but I do have a lecture note which is available by ordering at the first class, okay? This course consists of 8 chapters, and it starts with the single crystal growing, oxidation, diffusion, ion implantation, chemical vapor deposition, dry etching, lithography, and finally we're going to discuss about the metallization. And this all 8 chapters are the unit processes for the VLSI fabrication. And each chapter consists of 2 parts. Okay, the first half is about the theory for the process, and the latter half consists of the practical process, explaining the practical processes. For example, in a single crystal growing chapter, I'm going to introduce the theory as a theory heat balance equation to obtain the maximum crystal growing rate in the Czochralski growing. And then we're going to discuss about the dopant distribution, and I'm going to introduce another crystal growing technique which is called the flow zone technique. Okay, and for diffusion as a theory, I'm going to discuss about the fixed second law in order to obtain the diffusion profile after the solid state diffusion, and we are going to discuss about the processes like diffusion system, N-type and P-type, and measurement of the junction depth. And as advanced topics, I'm going to cover 3 topics: the lateral diffusion, field-aided diffusion, and the concentration dependent diffusion. And we move to the next chapter, which is oxidation. And as a theory, we're going to talk about the drill and groove model to understand the growth kinetics of the silicon oxide. Okay, and then as a processes, we're going to discuss about the charges in the SiO2, silicon oxide, which tremendously affect the transistor electrical properties. Okay, and as advanced topics, we are going to cover 4 topics as shown here, and then we are going to move to the ion implantation. Okay, as a theory, we are going to cover the LS as a theory to find out the projected range, in other words, the junction depth after the ion implantation. And the processes we're going to discuss about the channeling, tailing, and the damage and the recovery. The damage, it is unavoidable because it's a physical collision basically. And then we move to the chemical vapor deposition and epitaxial growth kinetics as a theory, and then we are going to discuss the various phenomena related to the chemical vapor deposition process. Okay, and we move to the dry etching chapter. We're going to discuss about the plasma as a theory, and then as a process again, we're going to discuss about the dry etching systems and the 4 systems shown here. And then we move to the lithography. In the lithography, we are not going to introduce a theory behind this, but we are going to discuss about the chemistry related to the photoresist. Okay, and then exposure system and the future trends in the lithography. And finally, for the metallization, it's a phenomenological phenomenon, phenomenological chapters. So there is no particular theories behind us, but we're going to start with the comparison of different thin film techniques, evaporation, sputtering, and CVD. Especially we are going to discuss about the step coverages with severe topologies, okay? And we're going to discuss about the problems and the solutions. And this metallization is a back-end process overall, so it is very much related to the reliability problem, okay? This reliability issue is very important in the industries. So in the metallization, this reliability issue is particularly important, and understanding of this relationship between the metallization process and the reliability is very important. Okay, that's pretty much introduction of the course. And then again, if you have any questions, you can call me anytime, okay? And I'll see you in the class. Thank you.